And this matrix multiplication operation has an inverse operation. Let me introduce the inverse matrix. So for n times n matrix, so for a square matrix A, its inverse matrix, which we denote by A to the minus 1, is at the matrix that satisfies the following. If we multiply A by this inverse matrix, we get the identity matrix, and also if we multiply A by n inverse, we get identity matrix. So this is a definition of inverse matrix, and now the question how to find this, and we have a good algorithm. So first that we do, for example, let me just show this on this example. For example, we're given a matrix 1 1 3 2 1 0 1, and to find inverse we write this matrix, the same matrix A, together with the identity matrix. Then what we do, we make some row operations. So here we make row operations to get the identity matrix here, and here some other matrix, and this matrix will be A inverse. And what are these row operations? The first thing, this we can interchange two rows, so we can interchange rows. Then we also can multiply a row of this matrix by some non-zero scalar. Multiply a row by scalar. And also we can add scalar multiple of row to some another row. So add rows. So by these three operations we do something to get the identity matrix on this side, and the rest part will be A inverse. So let me show you how this can be done. So the first thing that we do, this is very similar to Euler Jordan elimination. So we write the first row, leave it unchanged, and the first step we get rid of this thing here and this thing here. So what should we do to do this? We may multiply the first row by -1 and add to the second row, and multiply the first row by -1 and add to the third row. So let's do these things. -1 plus 1 is 0, -2 plus 3 is 1, -1 plus 2 is 1, -1 plus 0 is -1, 0 plus 1 is 1, and 0, 0, so we have 0. -1 plus 1 is 0, -2 plus 0 is -2, -1 plus 1 is 0, -1 plus 0, -1, 2 zeros here and just 1 here. So next we need to get rid of this thing to make this matrix triangular matrix. So the first thing, we get rid of all elements which are under the main diagonal. So what should we do to get rid of this one? We first rewrite the first row, we leave it unchanged. We rewrite the second row, and to get the third row we multiply the second row by 2 and add to the third one. So multiply by 2, 0 plus 0 will be 0, 2 minus 2 will be 0, 2 plus 0 will be 2, minus 2 plus minus 1 will be minus 3. So here we have 2 and here we have 1. So 2 times 0 plus 1 is 1. Okay, now we get the triangular matrix. The next step, we have to get rid of these two terms. So now we kind of come back. So the first thing we rewrite now the last row. And to get rid of this one, what we have to do, we multiply the second row times minus 2 and add to the third row. So minus 2 plus 0 is, so this is 0, is minus 2, minus 2 plus 2 is 0, minus 2 plus times minus 1 is 2, minus 3 is minus 1, minus 2 plus this 2 is 0, minus 2 plus 1 is 1. And we have to get rid of this one here, so what we do, we multiply the first row by minus 2 and add to the third row here. So the first row by minus 2 and add to the third row, we get minus 2 here, minus 4, minus 2 plus 2 will be 0, minus 2 minus 3 will be minus 5, minus 2 times 0 is 0 plus 2 will be 2, and minus 2 plus 1 will be 1. And finally, we need to get rid of this minus 4. What can we do to get rid of this minus 4? First, we rewrite the last row, minus 3, 2, 1, 0, minus 2, 0, and the second row as well. And now we will change the first row. To get rid of this minus 4, we multiply the second row by 2, by minus 2, right? So multiply the second row by minus 2 and add to the first row. Minus 2 plus minus 2 is minus 2. Minus 2 times minus 2 is 4, plus this minus 4 will be 0. Between two zeros we get 0. So 2 minus 5 will be minus 3. Here we have 2. Minus 2 plus 1 will be minus 1. So when we are almost done, we almost get the identity matrix here. Only the problem is that we have not ones here, but here we have minus 2, and 2. Next we divide the first row by minus 2, the second row by minus 2, and the third row we divide by 2. So what do we get? We get 1, 0, 0, 0, 1, 0, 0, 0, 1, and on this side we obtain 3 over 2 minus 1, 1 over 2. Here we divide by minus 2, so this will be a half, 0, minus a half. This we divide by 2 minus 3 over 2, 1, 1 over 2. So this thing is our identity matrix. And let's check that this is indeed identity matrix. So we have to multiply this matrix by the original matrix. So let's do this. We have to multiply 1, 2, 1, 1, 3, 2, and 1, 0, 1 times our inverse matrix, which is 3 over 2 minus 1, 1 over 2, 1 over 2, 1 over 2, 0, minus 1 over 2, and minus 3 over 2, 1, 1 over 2. Okay, so 1, so the first term of the product will be 1 times 3 over 2 plus 1 minus 3 over 2. This will be indeed 1. 1 times minus 1, 0, and plus 1 minus 1 plus 1 will be 0. 1 times a half minus 1 plus a half, so a half minus 1 will be 0. 3 over 2 plus 3 over 2 will be 3, and minus 3 will be 0. Minus 1 plus 0 plus 2. Minus 1 plus 2 will be 1. A half minus 3 over 2 plus 1. So a half minus 3 over 2 will be minus 1, and plus 1 will be 0. 3 over half, 3 over 2, 0, and minus 3 over 2 will be 0. Minus 1, 0, plus 1 will be 0. A half, 0, and a half will be 1. So this is indeed identity matrix. And you can check that if we multiply in the other order, the same matrix by our original matrix will give us also identity matrix. So check this, please.